In this section, we're going to take a look at a few CPU operations that can maybe make life a little bit easier when we're trying to get synchronization between two different processes. In the last section, we talked about something called Peterson's algorithm. Peterson's algorithm, though, well, it's interesting. It's obviously very complicated, right? So a natural question to ask is, how can we do it easier? So that's effectively what we're going to take a look at. So the title of this section is Synchronization Hardware. Really, it's just going to be about instructions. So the first one here, right, is test and set. Before I go through this, let me introduce a couple of ideas. First of all, right, is the idea of a lock, right? So there's a way we basically want, what we want is a way to say, okay, this particular resource, for example, a variable, right? I'm using resource very generally there. I only want, one process to be able to change it at a time, right? I don't want two people to be competing, right? And all of a sudden I get this, bad value at the end, right? I want basically a way to lock it, right? I want a way to lock it such that only one process can use it at a time, right? And then once it's done with it, right, it does an unlock, and then somebody else can mess with it. Right? Somehow the point is, I want to make sure that only one process out there is using my particular variable, my particular resource at a time. So that's one idea. Another idea basically is the idea of making something atomic. So the idea of making something atomic is to say we have maybe some maybe several operations, right, that come together, right, and they're all going to be performed as if they were one, right? Normally in terms of operations, right, you might think of something like a move or a store or something like that. Those are, by themselves, right, those do very simple things, right, and those are atomic, right? So I either, successfully do a move, successfully do a load, right, or I don't, right? Those are kind of one piece. Flip side here, right, is basically say, okay, you know what, maybe we can make larger units, right? We can make larger units and maybe have different operations combined together, and we'll basically want to treat them as if, if they either all run or they don't, right? So there's nothing about this idea of, only some of these instructions run and then, the other ones are paused for a little bit while something else ran. Instead, what we want to say is these sets of things all run exactly at one time, right? And it may be a little bit more complex than we're used to, right, when we say a single operation. So this is kind of the notion of basically an atomic function, right? A bunch of code that all gets executed at once. All right, so the two functions we're going to be discussing, right? The first one is test and set. The next one's going to be compare and swap. Both these are atomic functions, right? Meaning that we will execute basically one line of code, and it's going to act as if it's one atomic instruction, right? So the whole thing is going to be executed, or it's not going to be executed. It's just in one go. All right, so there's a bit of code over here on the right-hand side that we can take a look at for a second. And you can see in there, right, our call basically a test and set. So test and set is going to be our special thing we introduce. The idea here, right, the problem we're trying to solve, right, when we introduce this function is, well, say you have a variable, right? So you have a variable here, or I have, well, I don't really have an example in my code here, but just imagine, right, you have a variable, right? And I want to maybe set the value in that variable equal to something. One of the issues I can have, right, if two things running in parallel is, oh, hey, maybe I don't set the final value there, right? There's this idea of, I have two things that want to set the same variable. Maybe only one of them, right, gets to set it, right, and the next one gets to set it as well, right? And maybe it's, overrides the value of the first one, right? That's a little bit of an issue, right? Really what I want to do is I want to be able to set something at the same time that I know what it is, right? I want to basically read the value, right, and set it at the same, and in one go. That's actually what test and set will get me. So looking here basically at this function, right, so it takes only one argument, right, so this is my lock variable, right, so you can see my lock variable is basically defined as a boolean up here. And what's going to happen, right, is I'm going to try and set it to true, right, I want to set it to true. That's just kind of the default, it's not letting me, pick a value, I just want to set it to true. And notice, right, it's trapped inside of a while loop, and so actually what this function does is it returns what is the value that you're setting. The idea somehow, right, is I want to be able to set a value and see what it is that I changed, right, or maybe what it is that I didn't change. Now, because this is in a while loop, right, if that function returns true, it'll continue looping, right? So it'll be that little busy waiting there, right, and it won't jump down. Notice the way this problem is phrased is in terms of the critical section problem, right? So I have basically the code here I want to guard in the critical section, right? Once I guard it, right, I can do some other stuff. So that loop, right, will run while that function returns true. Well, if that function returns the value of the variable that it's looking at, right, then it's basically going to loop while that variable is being read as true, right? So what that's somehow doing, right, is it's checking to see, okay, I'm trying to set this to true. If it is true, I'll continue to loop, right? Because I don't want to be, right, I don't want to set it to true and then continue on, right? I mean, the variable might be true, but I'm not the person who set it to true, right? And that's an issue, right? So I just want to loop, right? And so let's say at some point, right, this lock is false. Well, in that case, right, that function running will turn it to true, but that function, right, also is going to return the value that was there, and so it'll return the false. If it returns the false, then that while loop will exit out, right? So it'll break out and drop down. So basically, right, what this is doing, right, is looking at kind of two cases, right? You have either a kind of a true going to a true, right? In which case that loop will continue looping, or right, it's going to be a false going to a true, right? So the true on the right-hand side is me always setting it equal to true based on me running this function. Left-hand side is what is there before, right? Because what is there before is what I'll be returning, right? And you can see, right, that if I have a true there, right, I'll just return it and I'll loop forever. First time I get a false, right, I'll definitely turn it to true and then break out of the loop, right, jump down and run my code, right, and then get down to my critical section, right, do my stuff, and then I can set that lock equal to false, right, basically release it so somebody else can use it, and then eventually you have my remainder, right, and in the example here I kind of just jump back up and I loop, right. So this is one idea, right, so this can basically serve as my guard before I get into that critical section area. The next idea I have to talk about is compare and swap. Compare and swap is, well, it's similar, but it's trying to solve basically a different problem. So here's a thought. Let's say I have something like an if statement, right? So I have if, if A, do B, right? Imagine I have code like that. This code, in terms of multiple processes running, right, can be a little bit problematic. Because if you think about it, well, maybe one process is running, it evaluates A, that ends up being true, and so it jumps down, wants to do B, right? But then all of a sudden another process, kind of preempts it, right? Comes along, wants to run, and that other process, right, does something that changes the value of A, so that A is no longer true. Right, so that really, right, if that first process was to go back and do that check again, it would realize that, oh, no, I shouldn't run B anymore, right? So that's kind of an issue, right? Is there maybe kind of a change, right, in the value of A, right, between when it's checked, right, as a conditional, and when I act on it, right, and run the codes instead of an if, right? That's a little bit of a problematic. So what we're going to do here is actually try to, solve this problem, but for maybe a restricted case, right? So we'll solve this basically for a case that looks something like this, right? I don't know, A equal 2, right? So I'll check A and then assign it, right? So this is a restricted case of what I just drew. This is the one that the compare and swap will basically try to address. So looking down here, right, this one's a little bit more complicated than the previous function in terms of arguments. So you have 3 arguments, right? So first we have the value, which is basically going to be the variable that we're examining. Then we have the expected value, right? So that's kind of, my comparison, right? So I'm checking, maybe A equal to 1 or something like that, right? Equal. What is it that I'm looking for, right? And then inside, what is basically the new variable, or the new value that I should set into it, right? So I have my 3 pieces, basically what I want there to be, right? What I do want to place there, right? And then the variable that I'm kind of modifying. So right hand side, right, I have another example. So initially, right, we have basically our lock variable, right? Here it's an integer, right? That's fine. It's not too much different than the previous example of the Boolean because it's just a 0 or 1 anyways. Then I have basically my compare and swap loop. So my compare and swap loop, right, I'm obviously, right, taking in the variable, right, that I had created earlier, and then I'm expecting basically to look at it, right, when it has a value of 0, right? That's kind of going to be what I'm expecting. And then, right, there's my value that I'm basically setting, right? So that's my assignment, right? So my 2 variables here, right, are somehow matching over here and over here. And maybe I can actually draw it out a little bit for you guys. So this code looks roughly like lock equal 0, right? Then lock equal 1. It's approximately what it looks like. That's the logic there. All right, now in the book's example, right, there's a couple different implementations of this. The compare and swap function, what it's going to do is it's actually going to return to me the value that's stored in that variable, right? So it's actually going to return that expected value, right? Well, not really the expected, but it's going to return whatever's inside of that locked variable, right? And so that locked variable, right, basically what it is, right, is I want it to be equal to 0, right? I want it to be that expected value. And so in this case, right, that is being checked over here with the not equal 0 conditional there, right? So basically what we're saying is that compare and swap returns the value of the variable. If it's not equal to 0, then go back and loop again and loop again and loop again, right? Again, 0 is the thing we want to see, and we want to change it to be another value, right? And so in this sense, right, it's a little bit like what we saw on the previous slide, but somehow a little bit more generic, right? Here I can have kind of more values in there, right? It doesn't have to be a 0, 1, right? If I want to, I can check for anything, right? And that would kind of influence both my expected over here as well as my conditional over here, right? And so if I do that, right, then I can hopefully get this behavior of basically an if that happens atomically. And so let's say I do get it right. I do basically have that lock equal to 0, right? I'm able to set it to 1. Well then, right, that's basically the same thing as the previous example where we jump down to the critical section, do our stuff, right, then set lock to 0, and then loop again, right, and then go again and again and again. All right, so that's 2 examples basically of some specific hardware, right, that could be used to hopefully implement, our atomic operations or our synchronous operations a little bit easier than something like Peterson's solution.